Assalamualaikum students. Today our topic is related to variation of g. G means acceleration due to gravity with height. As we are going to find that the g varies with height, it varies with depth as well as it varies with what? It varies with the rotation of Earth. So let us first going to find out the variation of g with height. We know the value of g on the surface of Earth, that is equal to what? Value of g on surface of Earth, g equals to what? G m over r square. This equation number first. Now let's consider a body at a height h from the surface at point A, where we will say gh is the value of acceleration due to gravity. So gh equals to what? G m over. Now as the body was pushed here, then from the separation from the center of Earth, they were having a distance of r. Now the body is at a distance of r plus h. So we will place it here, right? R plus h ka whole square. This is equation second. Simply, acceleration due to gravity on the surface of Earth is g equals to gm by r square. But acceleration due to gravity at some height h is gm over r plus h ka whole square. Now if we are going to divide them, it will be gh by g equals to gm by r plus h ka whole square divided by g, and g's value we are going to reciprocal it out here right now. It will be r square over gm. This gm is going to leave with this gm, and we will be having an equation of r square over r plus h ka whole square. This is gh by g. Now this is one of the equations which you have to remember, that gh, acceleration due to gravity at some height, is equal to g, the value of acceleration due to gravity on the surface of Earth, times the r square over r plus h ka whole square. We have to remember this very equation. Now this equation is valid when we are having heights very large, comparable to the radius of Earth. 1000 kilometer, 2000 kilometer, 2500 kilometer from the surface of Earth. Then we are having this very equation is valid. But we are going to change this very equation. We are going to make a bit change in this very equation like this. We'll place like this: gh equals to g of, now in the numerator we are having r square, but in the denominator we can make it like this. I will take here, it is r plus h ka whole square. I will take the r common, that will come out along with the square. It will be r square. Let's find it out like this: 1 plus h by r whole square. Let's find it out. If we are going to take r inside, it will be r. Here it will be r. R and r will leave. It will be r plus h ka whole square. Again the same thing. This r square is going to leave with this. Now what we are having? We are having gh. We are having gh equals to g of 1 plus h by r raised to power minus 2. Because it was in the denominator, I took it in the numerator. It will become as 1 plus h by r raised to power minus times the power here. Now as h is less and less than r, now this is the case which were, this equation is valid when the heights are very large. Heights are comparable to radius of Earth. And the equation which we are going to derive now, it is valid when h is very small. You can see 3 kilometer, 10 kilometer, 12 kilometer, 15 kilometer, 100 kilometer, then this equation will be valid, which we are going to calculate. As h is very very less than r, then we have to use using then binomial theorem. Using binomial theorem, what is that? If we are going to expand it, it will be becoming like this: gh now equals to g of, it will be like this, 1 plus of n is minus 2, h by r. As the higher powers, then it will be n into n minus 2 h by r ka whole square. But we have to neglect what? I will write neglecting higher powers. So what will become as, it will be like this. Now gh equals to g of 1 minus g of 1 minus 2h by r. This is the variation of g with height when the heights are very very small, heights are not very large. So this equation as this very equation, you have to remember the both. This is valid when the heights are comparable to radius of earth. This is valid when the heights are very very small. This is all for today. Tomorrow we'll be with another lecture. Till then, Allah Hafiz.